Okay. We're dealing with fractions. So, there are three main types of fractions. There's the simple, proper, or top light, some people like to call it. There's the improper, or the top heavy, and finally there's the mixed. Okay? When we talk about the simple, proper, or light fractions, I will use letters to represent. So, a fraction has a simple or proper fraction would look like a over b, but in the case of a simple fraction, I'm calling it simple, you can call it proper, you can call it top light, a is always less than b. Okay, so the top number is always less than the bottom number. That's why it's called, in some cases, top light. So some examples you might find, just pick two numbers. The smaller number goes on top, the bigger number goes on the bottom. Okay? Now, in the case of improper fractions, if we have the same a over b, okay, the difference is it's top heavy, or in this case, improper. So a is bigger or greater than b all the time. So it would be things like 7 over 5, 3 over 2, 4 over 3, and I could carry on. Now, for the mixed fraction, it is a mixture of a whole number and a proper fraction. Okay, so a is greater than 0, so it's a whole number. So it could be 1, 2, 3, 4, 5, 6, anything. Okay, so it's a whole number. And b over c, proper fraction. Okay, like we talked about at the top here, where the top number is less than the bottom number. What are the examples I'm talking about? So something like 1, 2 over 3, where 1 is the whole number, 2 over 3 is the proper fraction. Okay, carry on. 3 over 5, another example, or 7, 1 over 3. Okay, now it's important to also note this. Okay, mixed fractions can be written as this. So the whole number and the proper fraction is as a result of the whole number being added to the proper fraction. So they can just literally be slapped up against each other like this. So 3 over 5 is the same as saying 3 plus 3 over 5, okay? Or 7, 1 over 3, same as saying 7 plus 1 over 3, okay? Now, important things to note about fractions, okay? So you don't get tripped up. When you see this line here, okay, even though we say 1 over 2, it's the line that signifies division. It's the line that says it's 1 divided by 2, okay? Make sure to always keep that in mind. 1 divided by 2 is what can be written as 1 over 2. In the case of a proper fraction, 7 divided by 4, okay, can be written as that, and can move on to this. Okay, that's very important to remember. And secondly, whole numbers can be considered as fractions. Okay, so for example, when I decide 2 is the same as 2 over 1, which is also a version of an improper fraction or top-heavy fraction. Okay, 3 can be described as 3 over 1. 17 can also be described as 17 over 1. Now this is important to note because it will be brought up, okay, when you're solving with fractions in different cases. So this is something to remember, okay? Now, something I forgot to mention earlier is the relationship between mixed fractions and improper fractions. Okay? Mixed fractions is another way of writing improper fractions. So they're closely connected. You can convert from mixed fractions to improper fractions, and you can convert from improper fractions or top-heavy fractions to mixed fractions. Okay? So we're going to be looking at how to do that now. So if I consider that my mixed fraction is my whole number a and my proper fraction b over c, if I want to convert it to an improper fraction, okay, the bottom number stays the same. The first thing I do is multiply the whole number by the bottom number, so I put that in a bracket. So you do that first, and then you add the existing top number b. Okay, so let's see that with numbers. So if I say 1, 2 over 5 as an improper fraction, I know my bottom number from the proper fraction stays the same. So I put that here as 5. For the conversion at the top to get the number, that would be my whole number 1 times the bottom number, which is 5, plus 2. Now I'm supposed to do this first. 1 times 5 is 5, and then I have to add 2. So that's really 7 over 5 is an improper fraction. Okay? Now, once again, 3, 2 over 3. Now, the reason why I'm showing this numbers repeating itself is because I just want you to see that the process doesn't change no matter what the numbers are. Okay? So go again. The bottom number of the proper fraction becomes the bottom number of the whole thing. Okay? Next thing, you multiply the bottom number by the whole number. So the whole number is 3, and the bottom number is also 3. Okay? Block that away in a bracket, and then we know we have to add the top number of the proper fraction at the end. So that's 2 in that case. So our bottom number is still 3. 3 times 3, we know that's 9. We add the 2, and that results in 11 over 3. Okay? Cool. One more. Okay? First thing, decide the bottom number. It's the same as the one in the proper fraction here, 4. How do I get the top number? The first thing I do, I multiply the whole number and the bottom number. Whole number and the bottom number. So 7 times 4. And then after that, I add the top number of the proper fraction, 1. And so that follows. The bottom number is 4. That doesn't change. 7 times 4 is 28. Plus 1, we end up with 29 over 4. Okay? That's converting mixed fractions to improper fractions. Now, why is this important? Because anything you're trying to solve, you do not solve with mixed fractions. Okay? Whether you're doing addition, subtraction, multiplication, or division, you always convert mixed fractions to improper fractions before you start any calculations. Okay? To avoid any confusions and problems. Okay? Converting improper fractions or top-heavy fractions to mixed fractions. Okay? Now this method has a lot to do with long division, okay? And what we find as the remainders, okay? So, once again, we remember that improper fractions, if we represented it with letters, okay, A over B, then we know that A is bigger or greater than B, okay? So, if I considered 11 over 4, and I wanted to convert that to a mixed fraction, okay? Remember I said this is the same as saying 11 divided by 4, okay? So I take that to a long division, okay? 4 in 1, the number of 4s in 1, that's 0. The number of 4s in 11, that's 2, okay? That results in an 8 here, and we subtract, making 3, okay? So, 11 divided by 4 is 2, remainder 3. But how does 2 remainder 3 create the mixed fraction, you may ask? 2 is the whole number, 3 is the top of the proper fraction, and 4 is the bottom number, okay? So this came from here to here, this here to here, and the bottom number, like I said, never changes. Okay, we can repeat this again. So, if we decide that we wanted 7 over 5, okay, remember this line is the same as saying 7 divided by 5, okay? So we take it to the division table. Now, the 7 goes on the inside, the 5 goes on the outside. Now, how many 5s in 7? Now, I'm just going to do this, okay? Create the 5 times table. 5 times 1, 5. 5 times 2 is 10. So, we're looking for number 7 in here. In the 5 times table, there's none. So we take the number just less than. So in that row, that's where we find the number of 5s in 7. So that's 1. And we take the answer from that line to check for remainders. So that's 2. So 7 divided by 5 is 1, remainder 2. Now how do we take this information and create a mixed fraction? The answer you get is the whole number 1. The remainder is the top number 2, and the bottom number is exactly the same as the beginning, 5. Okay, so 7 over 5 as a mixed fraction is 1, 2 over 5. Okay, now reducing fractions, or some people like to call it simplifying fractions. Okay, this is where you find common factors between the top and bottom number and cancel them out for 1 and 1. Okay, so this involves breaking the numbers down into a product of prime factors and cancelling common factors out between the top number and the bottom number. Okay, for example, 4 over 6. To reduce this or to simplify this, the first thing I do is I take 4 and I break it down. So 4, the other number that goes with 2 to make 4 is another 2. So 4 is 2 times 2. Okay? Now 6 is an even number also. So 2 is a factor. The number that goes with 2 to make 6 is 3. So 6 is 2 times 3. I have 4 equals 2 times 2. So instead of 4, I have 2 times 2. And instead of 6, I have 2 times 3. Okay? Now, there's a 2 at the top here and a 2 at the bottom here. Okay? So I cancel them out for 1 and 1. Okay? Now, I can then say 1 times 2. That's 2. 1 times 3. That's 3. Okay? So, 4 over 6 simplified is 2 over 3. Okay? Now, if I considered reducing 12 or simplifying 12 over 45, okay, once again, I would take 12 and I would break it down. 12 is an even number, so 2 is a factor. The number that goes with 2 to make 12, if you don't know, you can do that by 12 divided by 2. That should be 6. Okay, circle that. That's a prime number. So 6 is an even number, so 2 is a factor. The other number that goes with 2 to make 6 is 3. So I circle both of those, they're prime numbers. So 12 is 2 times 2 times 3. And 45 ends in a 5, so 5 is a factor. The number that goes with 5 to make 45, if you don't know, carry out 45 divided by 5, but that should be 9 if you know that by heart. 5 is a prime number, so we circle that. 9 is not, but 3 is a factor of 9. The number that goes with 3 to make 9 is another 3, and they're both prime numbers, so we circle both of them. So 45 is equal to 3 times 3 times 5. What then results is, instead of 12, we now write it as a product of its prime factors, 2 times 2 times 3. We do the same for 45. So 3 times 3 times 5. Now, we compare the top and bottom. There's only one common factor, and that's 3. So we cancel that 3 out with an exact 3 at the bottom for 1 and 1. At the top, we then have 2 times 2, which is 4, times 1, which is still 4. And at the bottom, we have 3 times 1, which is 3, times 5, results in a 15. So, 12 over 45 as a reduced fraction is 4 over 15. Okay? Now, this can also be done for other fractions. Okay? Okay. So these are the next two fractions that we want to reduce or simplify. And, okay, start with 65 over 26. So we take 65, and then we go, it ends in a 5, so 5 is a factor. The number that goes with 5 to make 65, if you don't know that, long division, 65 divided by 5, you end up with 13. Now, 5 is a prime number. Remember, you should know your prime numbers from between 1 and 20 by heart, because 13 is a prime number. So we start. 65 is 5 times 13 as a product of prime numbers. or its prime factors, shall we say. And 26, it ends in a 6. That's an even number, so 2 is a factor. Now, what goes with 2 to make 26? You don't know. 26 divided by 2 in a long division, that will result in 13. Okay, 2 is a prime number. 13, as we established, is also a prime number. So 26 is 2 times 13. So we go back and we take 5 times 13 and replace 65. And we go 2 times 13, we replace 26. Now, we check for common factors between the top and the bottom, so that's 13. We cancel them out for 1 and 1. And then we go 5 times 1, that's 5. 2 times 1, 2. So 65 over 26 as a reduced or simplified fraction is 5 over 2. Okay? Now, 50 over 40. So we take that, break down 50. So it ends in a 0, so 2 is a factor, 5 is a factor, and 10 is also a factor. So, break that down. So I'll take 10. The number that goes with 10 to make 50 is 5. Okay? Now, that's not all the way broken down. Okay? 5 is a prime number, 10 is not. So 10 ends in a 0, so 2 is an automatic factor. 10 divided by 2 is 5. Those two are prime numbers, so I circle them. So 50 is equal to, gather all the circled numbers, 2 times 5 times 5. Okay? Now, for 40, it ends in a 0, so 2 is a factor, 5 is a factor, 10 is a factor. So, we take 10. What goes with 10 to make 40? If you don't know, that's 40 divided by 10. That should give you 4. Both are not prime numbers, so we keep going with each one. For 10, as we saw from 50, that's 2 and 5. They're both prime numbers. For 4, 4 is an even number, so 2 is a factor. The number that goes with 2 to make 4 is another 2. And they're both prime numbers. So, for 40, that would be 2 times 2 times 2 times 5 as a product of prime numbers or prime factors. Okay? So, we take 50 as a product of prime factors. That would be 2 times 5 times 5 at the top. And at the bottom for 40, that would be 2 times 2 times 2 times 5. Okay? Now, there's a 2 at the top and there's a 2 at the bottom. So we cancel that out for 1 and 1. Now there's a common 5 at the top and at the bottom. So we cancel that out for 1 and 1. Now, at the top, we then go 1 times 5, that's 5, and then 5 times 1, 5. At the bottom, we go 1 times 2, that's 2, 2 times 2, that's 4, 4 times 1, that's 4. So, 5 over 4 is the simplified version of 50 over 40. Now, one simple trick is this. When you have numbers ending in 0, you can slash the zeros off at the end. like so. So if we have 70 over 30, they both end in a 0. So what we just do is slash the zeros off. And we say it simplifies to 7 over 3. Okay? If we have 100, okay, over 70, the first thing we could do, okay, is slash 1 0 off. There are no more zeros to slash off, so that's 10 over 7. So, and that's one easy way of reducing or simplifying fractions that have a 0 on the end. Okay? Hope that helps. Thank you very much. You've been listening to the Math Done, and until next time.